So, as we've been discussing heat and transfer of heat and heat capacities and all of these sorts of things, one question you may have been asking yourself, and maybe not, is how do we know these heat capacities? How can we measure heat? And so what we're going to talk about in this video is the conceptual idea of how a bomb calorimeter works. This is one of the main tools that we use to measure heat. And this is often how things like calories for food are measured. We do these reactions in bomb calorimeter and measure how much heat is given off. So this thing here is called a bomb calorimeter. Doesn't involve any explosives. It doesn't involve combustion reactions generally. But let's talk about how this works. This is conceptually how we measure heat. So if we remember, heat is all about a temperature change. Right, heat is transfer of energy due to differences in temperature. And so to measure heat, what we're going to need to do is measure temperature. And so what we do is we do this inside of this special piece of equipment. And one of our main measurement that we're making is this thermometer right here, where we're measuring the temperature change in the calorimeter itself. Now, calorimeter is just a word that means heat measuring device, right? Calorie and calorimeter have the same root. If you happen to know Spanish, calor means hot. So this is all from the same Latin roots. And then meter, of course, is a measuring device. So a calorimeter is a heat measuring device. And so our main thing we're measuring in this is a temperature change. But what are we doing with this? And so the way the calorimeter works is that your actual process that you care about, your system, is right here, where it says reactants here. We put this inside of what's called a bomb. So this is a steel enclosure it's very strong, very thick steel walls. These things are really heavy, and it allows you to contain the reaction that's happening inside. And so you put your reaction, your chemical reaction, or substance that you want to heat up or whatever, reaction, but often a chemical reaction. And we'll talk about heat related to reactions as we move forward in the next couple of videos. But that's going to be your system. You put in, say, your food. So I've done this experiment before with, we used Altoid mint as our sample that we were measuring. And so this is often a reaction with oxygen, but it doesn't have to be with oxygen. But that's often one of the other reactants. So anyway, your reactants are inside here, and you have some way to start the reaction. So that's these wires, they'll circle in green here. These wires coming in these are just for ignition, as it says here. This is just to put in enough energy to actually get the reaction to start. So that's the whole purpose of those wires. And then surrounding our bomb, our system, our surroundings in this case is a bunch of water. So the reason we use water is, as we've discussed, it has a high heat capacity, and so it can absorb a lot of heat from our reaction that happens. And then all of this is inside of an insulated jacket. So this is our effort to try and make this as isolated as possible from everything outside. Because what we want to happen is we start the reaction, the reactants, it's usually a combustion reaction, the reactants react and produce the products. And in the process, they generate heat. Now, if it's an exothermic reaction, or you could do this with an endothermic reaction, and they will absorb heat from the water around it. So regardless, whatever happens inside of our system here, we're going to get heat exchange with the water that's around it, and with the steel and everything. And so you have a way of calibrating this to know how much heat it can absorb. So essentially, you measure the heat capacity of the whole calorimeter. Kind of like we talked about, like molar heat capacities or things like that. You can measure the heat capacity for the whole calorimeter. And then if you know that heat capacity, you can see how much did your temperature change, and use our equation that we've talked about. Q is equal to Cp times some quantity here. In this case, we don't have anything here. So it's Cp for the whole calorimeter. So it already includes the fact that it's not a mole or whatever, but this is something you measure and calibrate. and then you multiply it by the change in temperature. So you measure the temperature at the start of the experiment, you do the reaction, and you see how much does that temperature go up by. You have to know this value by doing a reaction where you know how much heat it produces, but once you have that calibrated, you can then find the heat for any other reaction you want to do. And so this is how we can measure enthalpies for reactions. This is how we can measure heat exchange with different things. Is we contain it, have this insulated jacket to try and keep the bomb calorimeter, the whole system, separated from the surroundings. So any heat that is generated by our reactants here just goes into the water, and we measure that temperature change of the water and everything else that's in it. An important part here is this stir. This is just to keep the water well mixed so that the temperature is consistent throughout the water, and that way your measurement with the thermometer is going to be accurate, and you're not measuring like a cold spot or a hot spot and get an inaccurate temperature. So this is the basic idea conceptually of how we measure heat values, how we measure heat capacities, how we measure enthalpies related to reactions. So in the next video, we're going to look at, once we've measured that, we're not going to do your book has some examples with questions involving like actually calculating calorimeter constants and things like that. We're not going to worry about that in this class, but I did want to at least introduce the idea of a bomb calorimeter and how it works. But we're going to focus instead on using the values that you get from a bomb calorimeter. Once we have those enthalpies related to a specific reaction, what can we do with that to figure out how much heat is going to be absorbed or released depending on a reaction and the enthalpy that's already been measured for it.